So going in the box, it says the sequence is arithmetic, and the difference between the consecutive terms are the same. So the sequence A1, A2, A3, all the way to AM is arithmetic if the number D, such that A2 minus A1 is equal to A3 minus A2, which is equal to A4 minus A3. All those common differences equals the same number. The nth term of the arithmetic sequence is written as this. Whoops, I need to use a pencil. A sub 1 plus D, which is that common difference, times n minus 1. Where D is the common difference, and arithmetic sequence can be thought of as a linear function. So if we're having a common difference every time, so we're looking at the same rate of change. So the idea is every single number going along in the sequence will change at the same rate with adding or subtracting by the same number. So it says, find the formula for the nth term of the arithmetic sequence whose common difference is 5 and whose first term is negative 1. So we'll take that and we need to find the nth term. So A sub n is equal to, and we plug in everything we know. So the first term is negative 1, so that's negative 1. A sub 1, remember, 1 represents the term number. So A sub 1 equals negative 1. And then we go on to say and then finish off the equation. Plus, what's the common difference? Did it state in the problem? 5 times n minus 1, using the formula. And so with that, we go ahead and clean this up. All right? So we distribute the 5. A sub n is equal to negative 1 plus 5n minus 5. Finish off with A sub n is equal to 5n minus 6. So, as you notice here, guys, this formula, the process should look kind of similar to what you've done in Algebra 1. Because in Algebra 1, you had this formula here. Do you remember that formula there? Point slope formula? Well, if we were to take this and rearrange it, it would turn into what this looks like with different variables. That's all. So it should be the exact same process. That's why in the notes it says it's a linear function. We're dealing with the same linear type of problems we did in Algebra 1. So, with that, find the formula for the nth term of arithmetic sequence whose common difference is 3 and whose first term is 2. So, A sub n is equal to, well, 2 is your first term, plus 3, that common difference, times n minus 1. Distribute the 3. 2 plus 3, n minus 3. And you get the equation A sub n equals 3n minus 1. Right now we're just plugging into the formula and simplifying. That's it. There's nothing fancy about this right now. And now we go on and look at the next one. So the next one goes on and says, find the formula for the nth term whose sequence is, and now they give you the sequence, and now you need to go ahead and find the parts. And the two parts we need to know is that common difference. Hang on, we got to go back. Change A sub 1 in the formula. Change A sub 1. Nope, it's perfect the way it is. Stop. Perfect the way it is. Sorry. Just don't even listen to me, all right? Right now. My bad. All right, so let's go on. Here, what's the common difference here, guys? Plus 4, minus 4? Plus 4. Is that the same here? Is it the same all the way across? Yes, it is. So we have the common difference of plus 4. I'll just put a little plus sign there. That's what that's supposed to be. And then what is our first term in the sequence? Negative 3. So go ahead and use the formula again. It's exactly what we've done before. Plugging everything we found out and simplifying. All right. So we're at the terms of arithmetic sequence. So guys, now we go ahead. The fourth term of the arithmetic sequence is 20, and the 13th is 65. So we need to find this common difference, okay? And you found it earlier pretty easily because they gave you sequential terms, 1, 2, 3, 4. So you just had said, okay, from 1 to 2, it was plus 4 was the values, was just adding 4. 2 to 3 was another plus 4. 3 to 4, all these terms adding up was the same one. So now they give us gaps in the sequence. So now we need to go ahead and just find those. So we do the exact same thing we did in Algebra 1, guys. How did you find that slope? What did you use? So we used, go ahead.
Y1, or Y.
But you have the right idea. Go ahead.
Y2 minus Y1 over X2 minus X1.
We're going to use the same concept, except we're going to go ahead and modify a little bit where the common difference is equal to a sub n minus a sub n minus 1 over the term number. So we're looking at n minus 1. Okay? And those are just within one. Or we can use different types of term numbers. So if you look here, it's basically, which comes to this, delta a sub n over delta n. Delta means difference, or change in. Change in a sub n over change in n. Well, look at this one here. We have our, fourth term and our 13th term. So change in 13 and 4 over or under the change in values. So the two values were 65 and 20. So 45 over 9, which gives us 5. So your common difference is 5. Well, we found one part. What are we missing now, guys? We're missing that first term. Well, we got a couple options here. If you know the fourth term is 20 and we're counting by 5s, or we're adding 5 every time, what do you think I'm going to do to get back to A1? Subtract. So I can go a sub 4 is equal to 20. A sub 3 is equal to 5 less than that. A sub 2 is 5 less than that. And A sub 1 is equal to 5. Which is not bad because they give us the fourth term. The next problem gets a little bit lengthier and we got to figure something else for the next one, okay? But for now, if it's a small number they give us, we can just count backwards to get to it. So we have everything we need to go ahead and plug into the formula. So A sub n is equal to your first term plus your common difference times n minus 1. Distribute. And simplify. Questions? All right. So now look at the next one. Eighth term of the arithmetic sequence is 41, and the 12th term is 25. So let's find that common difference again. Change in values. So what? 25 and 41. Don't always think it's going to be a positive, guys. Sometimes there will be larger numbers first or vice versa. Because again, we are dealing with, the common difference could be negative. We could be subtracting by a number every time. So 8th term to 12th term. So what, negative 16 over 4? Common difference is negative 4. So I'm going to come over here to the side. You know what? I'll put it right here. So then all that's left is finding a sub 1. Again, if you wanted to, guys, 41 is where we're at. Common difference is negative 1. So every time I move back, what am I going to have to do to that 41? Not add 4. We're subtracting. Now we're subtracting because we're going to the right. Now, since it's negative 4, we're going to have to add to go to the left, to go to smaller values. But let's go ahead and avoid that if we make that mistake. So let's go ahead and do this. We can do this. Plug in what we know and solve for A1. So if we know the 8th term, A sub 1 plus 5, 8 minus 1, we have this here, okay? And now I'm putting A sub 8 here, but here's the deal. Do we know what the 8th term value is? What is it? 41. I wrote A sub 8 first, just so you know where I'm getting that from. Yes? Because it's that common difference. I'm taking... Oh, what is it? Oh, negative 4. Oh, I'm thinking the previous one, aren't I? Sorry. There. You're taking that equation we talked about at the very beginning, and now what we're doing is we're plugging into one of the terms we know. We know the 8th term, that's there, value is 41. And so we plug in everything we know about the 8th term, and plug in and then leave blank what we don't know. And it just so happens what we don't know is what we need left to write our equation. Do y'all see that? The only unknown in this equation now is A sub 1. And let's solve for A sub 1. So we take the difference here, which is 7. And you end up with 41 equals A sub 1 minus 28. So you add 28 and it gets you 69 is equal to A sub 1. So now we know A sub 1. We know the common difference. And now we can create our equation. A sub n equals 69 minus 4n minus 1. Same thing as before. And guys, you can write any way you want. If you want to start with the about, you can start it just like you've done. In algebra 1, you did y equals mx plus b, right? This one you can do A sub n equals your constant minus your common difference, or you can do A sub n equals your common difference plus your constant. It doesn't matter, whichever version you want to do it. I could rearrange it this way as well. Get the same answer. Did I do something wrong? It's plus 4? It is, isn't it? So this should be 73. Thanks, guys. Thanks. There you go. And if you want, guys, this could be a quick check, which I would have probably done if I was wrong, because I could easily said, okay, if I plug in 12 for this negative 4, I have a calculator in my hand. Plug in 12 for negative 4, or for n. Negative 4 times 12 is negative 48, plus 73 is 25. I'm exactly right. You can check your work real easily. Alright, this one goes on to say, find the 10th term of the arithmetic sequence that begins with 8 and 20. So we know our first two terms. Okay, we know it's arithmetic, which means it's a common difference. So we go through and say, okay, well, let's find the equation first. What is the common difference from 8 to 20, guys? 12. What is our first term? 8. Let's write our equation real quick. If I can get this one right. So we end up with this as our equation. No. A sub n is equal to 12n minus 4 is our equation we're looking at. But it wants us to find the nth term. So it's where n equals 10. So let's plug that into our new equation we just got. So a sub 10 equals 12 times 10 minus 4. 120, so it is what, 116? Any questions? Good. Aiden, is that what you got? Yeah? Then it's right. It's what Aiden got. All right. The sum of finite arithmetic sequences. So the sum of it, well, here's the deal is if we take those and we say what is going to be the sum if we were to go up to a certain point. So now the idea is not only coming up with a sequence, but we're also coming up with what their sum is going to equal to as well. So, and you're like, at first, you're like, what is this important? Well, it could be important when you're talking about giving prizes and money to people in a certain event that you're going to sponsor. So you have a race that you're going to have, and the first team gets $1,000, second team gets $900, and so forth and so on. Well, if you come up with something like this, you're going to do 1,000 plus 900 plus 800 plus 700 plus 600, or you just go ahead and do a short version of it and say, hey, here's the money right there, quick, and we can see how much it's going to be. So the sum of it is using this equation here. Guys, all these equations will be given to you, so just heads up. You don't have to memorize them, you just got to know how to use them. And so it says, and how it works out is n is going to represent the number of terms, as always. A sub 1 is going to be your first, and A sub n is going to be your last term. So if you have a series of numbers, and now it's finite, which means it stops somewhere. Okay? If I go 1, 3, 5, 7, 9, in order to figure that out, I'm going to have to do the sum of it. Well, n represents the number of terms. 1, 3, 5, 7, 9. That's, let me go to 11, just to make an even number. That's 6 terms. So n equals 6. A sub 1 equals 1. And my 6th term is 11. So that's there. So it ends up being 1 plus 11 gives you 12. And it's times 3, so it's 36. 1 plus 2, 1 plus 3 plus 5 plus 7 plus 9 plus 11 is 36. Right there. So use only if the sequence is finite, which means it stops. Use when you know or can figure out the number of terms, A sub 1 and A sub n. We'll look at number 7. Number 7 kind of goes slowly through this. So sum of 1, 3, 5, 7, 9, 11, 13, 15, 17, 19. So the sequence is arithmetic with a common difference of what, guys? 2. Because if we were to look at each one of these numbers, so forth and so on. The sequence has how many terms in it? 10. So we can calculate the sum by this formula here. The sum of the 10 terms is equal to 10 divided by 2 times the value of your first term, which is what? Plus the value of your 10th term. What's the value of your 10th term?
14.
And that's how you work it, guys. Write the equation, plug in your number of terms, your first term, and your last term, and then simplify from there. So it says the sequence is defined by even numbers starting with 10. So our first term is 10. Okay, we know the common difference is what, guys? 2. Whoops. And so in order to find this, again, go up to the box. Use when you know or can figure out the number of terms. Well, how many number of terms are we going to go for? 50, right? Thanks, Allie, for answering. It's like it's just you and me. Just follow along. All right, we're going to 50th term. It says the sum of S sub 50. So now you can see why this formula is kind of important as well, because if I need to go out to 50 terms, that's not very fun adding 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, all the way out to 50 terms. Okay? This formula cuts that work down by significantly. So we know the first term's there, and we know the difference is 2. We know n is equal to 50. What are we missing in this part of the equation in order to help us use the summation equation? Yeah. Two common difference. It's even numbers. So 10, 12, 14, 16, 18, 20. What am I adding by every time, Josh, to get to the next term? 2. That's D. D is that common difference. So if you're counting by even or odd numbers, the difference is 2. Okay? If it said counting by 5s, well, then your difference will be 5, right? 5, 10, 15, 20. All right. So what are we missing to finish off this equation? A sub n, which is also, for this particular problem, a sub 50. Okay, we got to find a sub 50. Do we have any tools in our shed right now that can help us find a sub 50? We have the equation at the very beginning, don't we? Don't we have an ability to go ahead and go to one particular... We have an equation that we can create that'll help us get right to the value of that certain term, right? That's what we've been doing ever since we started the notes. So, let's jump into that equation and see what we got. A sub 50, which we don't know, is equal to... Well, what's the first term we have to do in order to make this one work?
10.
It is a sub 1, which is 10. What is our common difference? Times, what is n in this particular number we want? 50 minus 1. And look at that. We have an equation with all numbers on the right side. Was that 49 times... Double check me, please. As you can tell, I have a Monday head. So, not working out for me so well. Takes a village with me. You know that. Is 108 correct, guys? Okay. Actually, I just want to hear you. Yeah, I'm right. I don't hear much of the house, so I like to hear it here, so that's good. All right. So here we go. So our 50th term is 108. So now we have everything we need to use to plug into the formula that we originally talked about. So S sub 50 is equal to 50 divided by 2 times the value of your first term plus the value of your 50th term that we just found. And now from here we figure out what that value is. Oh, someone help me out with this. 2950. Thanks, Evan. All right. Questions, guys? Are we all still on the bus? Okay, I got a thumbs up in the back. That's good. Couple of head nods. All right. Here we go. Find the 150th partial sum of the arithmetic sequence who starts with 5, 16, 27, 38, and 49. 38 and 49. So, let's go again. Same thing we did on number 8, guys. Same thing we did on number 8. Let's go through. Do we know our first term? 5. Do we know this common difference that we're counting by? 11. Do we know what term we need to go out to? 150. Do we know the value of the 50th term? Or 150th term? No. So here we go. This is going to be deja vu, guys. So, use that to help you out. You know what? I'm just going to use this right here. A sub 150 is, well, we'll use the value of our first term. We're using the formula, guys, at the very top, right? What we did previously. What is the value of our first term? What's A sub 1? 5 plus, what's our common difference again? 11. And we are talking about the 150th term minus 1. What was that, 149? Anybody know their times tables up to 150? No? Anybody got a calculator? You're already adding the 5 to it? Okay. So it's going to be what, 1639? And then we'd go ahead and add. So we know the value of the very last term now. We know the value of the first term. We know the value of the last term. We know how many terms were going out. That's all we need to know to find the sum all the way up to then. So sum up to 150 is 150 over 2. 5 plus 1644 or 75 times 11649. So let me get that one. Pretty big number, right? It works. Yes. Oh yeah, sorry. Sorry guys, I'm cheap. If I pay $35, that thing goes away, but I'm not going to pay $35 for that thing to go away. So, I appreciate it. You guys. Be a nice gesture for it. We'll just wait till Christmas. How's that? All right. So any questions, guys, about summing finite arithmetic? Again, this is a finite one, which means it does stop. Okay? We're going to go ahead and sum all the way up until we get to a stopping point. And so some other way you might see it is in this summation notation. And so the idea here is, okay, they give us the equation, they give us how many terms we need to go out. We're just going to have to take this summation notation and kind of break it apart. Let's go ahead and go through what we were doing before, guys. A sub 1. So what would be our first term here? Well, if we plugged in, and what number are we starting off with in this summation notation? N equals 1. Good. What are we doing with that 1 or with n every time? Multiplying it times 2. So what is a sub 1? It's 2. Because again, guys, this tells you where you're starting. Sometimes this could be 3. This could be some different number besides 1. It doesn't always have to be 1. It could be even be 0. Okay, but you got to follow that guideline. So the first term in the summation notation is 1 plugged in from n, which is 2 times 1, which gives you 2. Okay? Then we go on and talk about this common difference. Well, let's just, for grin's sake, let's just go ahead and see what happens here. So if the first one is 2, what happens when I plug 2 in? Plug 3 in. And let's do one more. What happens when I plug 4 in? What's that common difference? 2. How many terms are we going out to, guys? 100. And then we need the 100th term. Do we know that one? Can we find? All we have to do is, we have the formula given to us now. We don't have to go in and solve for it like we did earlier, guys. We could just go ahead and say, okay, plug in 100 in for n. 2 times 100 gives you the value of that last term. So we have everything we need here to find the summation. Bless you.
Thank you.
Was that 1010? No. 10-100? What'd you get? 10-100? I know it's a weird way to say it, but... Yes, Sebastian.
Why didn't you have to use the equation from before?
Because with this type of setup, we can find the exact value of the last term. Because we can just plug it into the formula that's already given to us. See that 2n is there on the summation?
Yeah.
All we have to do is plug in 100 and we found it. So that's it. They didn't give us like a list of numbers or the first and maybe the 7th number. They gave us the equation itself. You got to find it in there, but it's in there, okay? So that's why we didn't have to plug it in. Or, you got your calculators, right, guys? Go to alpha window. You should see an option on there that says summation. You see it? Okay. When summation comes up, you're going to see this big sigma. You're going to see an empty space at the bottom that's waiting for you to put in a variable. Guys, for this, I'd recommend using X every time. It saves you a couple of button pushes, okay? So I would use X, the same X you use in Y equals. So in there, you can go ahead and say X equals 1. Press the up arrow to go on top of the sigma. Type in 100. Press the right arrow to get to the right of sigma. And type in 2 times whatever letter you used in the first part of this equation. So it would be X. Press enter. It's the same thing.
Why are we doing it?
Well, because I need you to see how to do it from this for multiple choice purposes. But yes, in your calculator, for the test, you're allowed to use a calculator, which means you're allowed to use this exact same thing. There you go. Now, I did have to go over it as well, guys, because there will be questions on there that'll say, using this summation notation, what are the first 6 terms of the series? Well, you're going to learn to have to plug in, start with 1, plug in 2 times 1, 2 times 2, 2 times 3, 2 times 4, 2 times 6. There's your first 6 terms of the problem. Do you see what I'm saying? Then it goes on to say, what is the answer to this, or what's the value of it? Then you can use your calculator, put in your summation notation, and you'll be fine. Okay? All right. Consider a job offer with a starting salary at $32,500 and an annual raise rate of $2,500. Determine the total compensation from the company through 6 full years employment. So this actually plays into effect, guys. So with that, you got to be able to say, okay, if I'm going to do this and give this top promise to this guy, can I fulfill it in 6 years? Because, I mean, after 6 years, he's getting a $1,000 raise. That's $6,000 more a year that he was making when he first started. Now, I want to say that, and also I got to back up and be like, can I still pay myself? Because, guys, at the end of the day, you still have to, as an owner of your own restaurant, you still got to consider yourself as an employee. Okay? You can't say, all right, everybody gets paid, bills are paid, whatever left over I get to keep. Sweet. It's a great month. This is awesome. Next year I have nothing. No, you got to give yourself a salary as well. So there you go. All right, so consider job offer, starting salary is this. So we go through and it says total compensation means we are looking for, and it says through 6 years. So we are looking for the summation up to 6. How much is he making his first year?
$32,500.
Thank you. Well, that's an interesting number. 32.5. So, how much, well, what's that common difference every year when we keep going? 2,500. Guy gets a $2,500 raise every year. Wouldn't mind that job. Starts off a bit low, but hey, 5 years there and I'm making some good money. So, for how many years? 6 years. So then we go through and say, okay, well, what is he making his 6th year? Do we know that right now? No, we don't have that information just yet. So what we're going to have to do is use the formula earlier. We don't have what we had earlier, which was nice, 2 times n. That formula is already given to us. This one's not given to us. So a sub 6 is equal to, bless you, your first times your common difference times 6 minus 1. So 5 times 2,500, so 12,500. Whoops. What was that, 4,500? 45,000? Am I right? Nope. Yeah, am I right? Am I right or wrong? Okay, thanks. So, and I wasn't even looking for that one just for ego boost. I really want to know was I right or wrong on that one. So $45,000. This guy started off at $32,500. Now he's making $45,000 after 6 years. How much have you paid for all those 6 years up to the last one? So, summation up to 6 is 6 divided by 2. His first year's salary plus his last year's salary and so you end up with 3 times 77.5, which is, Caleb, what you got? You want to just type that in the calculator? 3 parentheses 77500 close parentheses, press enter.
23.8.
Missing the 0.
Yeah.
It's alright. Zeros make differences, don't they?
32,500.
So after 6 years, this guy's made total compensation almost $250,000. Kind of something I need to think about as a business owner. This employee is really worth that after 6 years. So also it's things that NFL pro teams or pro teams always think about as well. Giving someone a contract, now we're talking about millions, of course. But the idea is it going to be worth it? After 5 years, when he is now 5 years older, is he worth that total compensation that we're giving him? Those are questions we asked, right? All right. So in a golf tournament, 16 golfers with the lowest scores win cash prizes. First place receives a cash prize of $1,000, second $950, third place $900, and so on. So what's the amount of total prize money we have to put together? Well, the value of your first is what? $1,000. Grand prize winner gets $1,000. What's that common difference? What are we doing every time as we move down places? The worse you get, the less you get is $50. What about how many terms are we going to go down? 16th place, right? And then finally, do we know what the 16th place is getting? We don't. So let's find it, right? Whoops, missing a 0. 16 minus 1. So 1,000 minus 50 times 15. Really working those calculators today, aren't we, guys?
Are we gonna get a calculator on it?
Oh, definitely. Yeah. Morgan, what'd you get? Heck yeah, 16th place gets $250? Sign me up. All right. So let's see what the total money is that this company is going to pay in order to run this type of show to give those, and just in prizes. So the sum up to 16th place, 16 over 2. First prize is $1,000 minus last place, which is $250. 8 times what? 750? 6,000? Because it's, oh, is it plus? Is it plus? Ooh, sorry. Brain fart there. Yes, it's a big difference, isn't it? That would be bad. Somebody get 8 times 1250?
10,000.
Oh, gosh. All right.